Have you ever wanted to make your own hot air balloon? Well, today I'm going to teach you how with my experiment, Flying Teabag Ghosts. Hi everyone, I'm Emily Calandrelli, MIT engineer and host of Emily's Wonder Lab, and on my channel we learn about all things space and science. So grab some tea bags because things are about to lift off.
Emily's Science Lab, stay curious and keep exploring. Emily's Science Lab, stay curious and keep exploring.
Today we are going to make our own hot air balloon with tea bags. What you need for this one is tea bags, but not every kind works. Twinings is a brand that works really well for this experiment. A bowl to put all of your extra tea in, some scissors to cut your tea bags open, markers to decorate our flying tea bag ghosts, and of course, a lighter. Parents and adults, because we are using fire, please exercise caution here. The first thing you want to do is open your tea bag, take out your tea, go ahead and unwrap that string there, and we are going to cut right along this line. It's important that you cut as straight as possible. So go ahead and cut a straight line right there. 1, 2, 3. And now we're going to dump out our tea. You can save this for later if you like. Now what we want to do, give it a roll, open up that little cylinder there, and make sure it stands up. If it doesn't stand up very well, you may want to cut it so that your cut is a little bit more even. Perfect. And now we can decorate our tea bag. He's going to be very scared because we're lighting him on fire. Oh no! And now here's the fun part. Set your tea bag up on a flat surface. Ready? Set. Go. Patience, 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 and watch our tea bag lift off. Go, 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 go. And that is our flying tea bag ghost. You'll notice that it incinerates really quickly. That's thanks to the fabric that tea bags are made out of. This is why the tea bags are perfect for this experiment, because they're so thin and they burn so quickly, and they're light so they can lift off. Our tea bag rose for the same reason that hot air balloons rise. When we lit it on fire, we heated up all of the air inside the tea bag. When air gets hot, it gets less dense, which makes it buoyant amidst regular air. And because our fabric is so thin and light, that allowed it to lift up the tea bag and make our tea bag ghost fly. If you're having trouble making your tea bag ghost fly, it's probably because of your tea bag. So you need a tea bag that folds out into a cylinder like this, but not all cylinders will work. Some brands have denser materials than others, and I'm telling you, Twinings tea bags work the best. Whoa! Flying tea bag ghosts! That was amazing. Thank you for making flying tea bag ghosts with me. If you like this one, be sure to check out my best-selling Stay Curious and Keep Exploring book series for 99 more science experiments. I'm Emily Calandrelli. Subscribe for all things science and space. And remember, stay curious and keep exploring. I'll see you next time.
Emily's Science Lab.
Have you ever wanted to make a watermelon barf? Well, today I'm going to show you how with my Barfing pumpkins experiment. Hi everyone, I'm Emily Calandrelli, MIT engineer and host of Emily's Wonder Lab. And on my channel, we learn about all things space and science. Now get outside because this fruit is about to be sick.
Emily's Science Lab, stay curious and keep exploring. Emily's Science Lab, stay curious and keep exploring.
First, I'm going to teach you how to make a barfing pumpkin. This one is great to do after Halloween when you have those jack-o'-lanterns and they're starting to maybe rot a little bit and you don't know what to do with them. Well, you can do science. So get your jack-o'-lantern, and you also need 1 cup of baking soda, 1 cup of vinegar, some food coloring, I'm gonna be using green because it's barf, and some dish soap. So what you wanna do is put 1 cup of baking soda inside your jack-o'-lantern, and you might need more if you're using a bigger jack-o'-lantern, just double the ingredients. Whoa, there goes our baking soda in the air. Ah, okay. Now go ahead and throw that into your jack-o'-lantern. This one's gonna get a little messy. Make sure we are outside doing this one, okay? Now put 1 cup of vinegar into another cup, and we are going to add some food coloring to our vinegar. So I'm gonna use green and add just like 3 or 4 drops of food coloring there. Mix up your food coloring, and now we are going to add our dish soap. You just wanna add like 2 big squirts. 1, 2. Get your jack-o'-lantern and pour in your vinegar. 3, 2, 1. Whoa! And there is your pumpkin barf! So how does this pumpkin barf work exactly? Well, we are doing a standard acid-base chemical reaction. Vinegar is your acid, otherwise known as acetic acid. Baking soda, or sodium bicarbonate, is your base. And when you mix the two together, you create carbon dioxide bubbles. But this isn't just bubbly, it's also frothy. Why is that? Well, that is where our soap came in. It trapped those carbon dioxide bubbles and made them not just bubbly, but also soapy and frothy, thickening up our pumpkin barf. Now we are going to do that same experiment, but in a watermelon. Full disclosure, I have never done this in a watermelon before, and we will see if this works together. So I've got my watermelon here. I've got my immersion blender. How do you turn this thing on? There we go. Oh, and I'm just going to put it in my watermelon and turn it on and turn it into watermelon juice. 3, 2, 1. Oh. Oh, there it goes. I've never used one of these before. These are quite effective. I'm gonna put some of this juice in a bowl. It's a side benefit of this experiment. You get some watermelon juice out of it. Parents and adults, obviously exercise caution here. Once you have hollowed out your watermelon, you are ready to draw on your face. So I'm just gonna use permanent marker here and draw on some eyes and a mouth. Just like that. And I'm going to use a steak knife to cut it out. I have never carved a face in a watermelon before. This is a first for sure. Ooh, it is surprisingly easy to cut, I will say that. Boop. We are ready for our watermelon barf. We are going to use the same thing we did before. I'm going to use, 1 cup of baking soda. Let's see how that fills up the watermelon. That should be fine. And I'm going to add just a full cup of vinegar, like not a measured cup, but just a full big old cup. And then we are going to add purple to this one. A whole bunch. This one is obviously very accurate and highly measured. Now add a few squirts of soap. We are going to make a watermelon barf in 3, 2, 1. Oh! It's so frothy. And that is how you make a watermelon barf. Thank you for making barfing pumpkins and barfing watermelons with me today. If you like this one, be sure to check out my best-selling Stay Curious and Keep Exploring book series for 99 more science experiments. I'm Emily Calandrelli. Subscribe for all things science and space. And remember, stay curious and keep exploring. I'll see you next time.
Emily's Science Lab.
Have you ever wondered, what are bones made out of? Well, we will learn the answer to this and so much more with my rubber bone experiment. Hi everyone, I'm Emily Calandrelli, MIT engineer and host of Emily's Wonder Lab. And on my channel, we learn about all things space and science. So grab your chicken bones because things are about to get weird.
Emily's Science Lab. Stay curious and keep exploring. Emily's Science Lab. Stay curious and keep exploring.
Bones are made up of a framework of soft and hard material. The soft material is made up of something called collagen. It's a protein that makes our bones a little bit flexible. The hard material is made up of something called calcium phosphate. This is what makes our bones strong. But as we get older, we start to lose some of this calcium, and that makes our bones weaker. That's why it's so important to eat foods that are rich in calcium and vitamin D, because vitamin D helps your bones absorb calcium. Here's what you need to make a rubber bone. Some chicken bones, clean them off with water and make sure that the only thing that is left is the bone. And here's a tip, the skinnier ones like this will work a little bit better for this experiment. A cup to place your chicken bones in, and some vinegar. You just need enough to cover the bones. So go ahead, cover your bones, just like that. And now we are going to let our bones sit for at least a week. The longer you let it sit, the better this will work. What is going to happen is your vinegar is going to react with the calcium phosphate, the hard part of the framework of your bone, and dissolve it, remove it, so that the only thing that is left is that softer collagen, making your bone a little bit flexible. So after a week, your bones will look like this. They don't look really any different to the naked eye. You can start to get a little bend in the bone. So it bends a little bit. That's after 7 days in vinegar. But now let's see what it looks like after 20 days. This is where things get really weird. Now look at this. Ooh, look at that bone. Look how flexible our bone is. That vinegar has now dissolved most of that calcium phosphate away, and all that is left is your collagen. Wiggle, 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 wiggle. Let's check our other bones. Oh, they're all so wiggly. Look at that. Are you kidding me? It's so weird. Ew. Okay, so this is what a larger bone will look like. A larger bone will take a little bit longer and it won't be as rubbery as those skinnier ones, but watch this. It's still quite flexible. Ooh, gosh, this one is not for the weak-hearted. I mean, that's a bone. Oh, this one's super rubbery. Look how rubbery it is. Thank you for making a rubber bone with me. If you like this one, be sure to check out my best-selling Stay Curious and Keep Exploring books for 99 more science experiments. I'm Emily Calandrelli. Subscribe for all things science and space. And remember, stay curious and keep exploring. I'll see you next time.
Emily's Science Lab.
What do you think will happen when I poke this bag of water with a pencil? Will water come out? What do you think? Today we will learn the answer to all of that and more with today's Unpoppable Spider Bag experiment. Hi everyone, I'm Emily Calandrelli, MIT engineer and host of Emily's Wonder Lab, and on my channel we learn about all things space and science. So grab your sealable bags and your sharpened pencils because we're about to make a spider.
Emily's Science Lab. Stay curious and keep exploring. Emily's Science Lab. Stay curious and keep exploring.
For this one, you will need a sealable bag, 4 sharpened pencils, and some water. I'm going to add food coloring to my water just because everything is more fun in color. First, grab your sealable bag, and we are going to fill it mostly to the top with water. Parents and adults, you may want to help with this one so the kids don't make a mess. Just like that. And go ahead and add a couple of drops of food coloring. Seal your bag, and to mix the food coloring, you can just shake your bag a little bit. We are ready to make our spider. Now what do you think is gonna happen when I poke through the bag with this pencil? Do you think the water is gonna come spilling out and mess up my dress and this table? What do you think? You ready? 1, 2, 3. Look at that. Let's do a few more, shall we? 1, 2, 3. Okay, 2 more. 1, 2, 3. And then finally, 1, 2, 3. Look at our spider bag. Why did this work? Why is there no water spilling out of our bag? Well, it all has to do with what the plastic is made out of. This plastic is what's known as a polymer. A polymer is made up of long repeating chains of molecules. It comes from the Greek words poly, which means many, and meros, which means parts or units. So many parts or many units. Basically, polymers are like flexible spaghetti noodles that are tightly packed. And when you poke a pencil through, it may break a few of those chains of molecules. It may break a few of those spaghetti noodles, but it will wiggle through and slip through the rest. And then what happens is those spaghetti noodles will snuggle up tightly around the pencil, creating a seal. There are polymers everywhere around us. All plastics are polymers, but not all polymers are plastics. There are natural polymers like silk, wool, and even human DNA. There are also synthetic, meaning human-made polymers. Things like Teflon that we have on cooking pans, or nylon, or even polyester, which is used in clothes. And they each have different special properties that make them unique. Thanks for making an Unpoppable spider bag with me. If you like this one, be sure to check out my best-selling Stay Curious and Keep Exploring book series for 99 more science experiments. I'm Emily Calandrelli. Subscribe for all things science and space, and remember, stay curious and keep exploring. I'll see you next time.
Emily's Science Lab.
Have you ever wondered, how do you know if something you've seen on the internet is fake? Well, today we are debunking some things we've seen online with my experiment, Monster Fingers. Hi everyone, I'm Emily Calandrelli, MIT engineer and host of Emily's Wonder Lab, and on my channel we learn about all things space and science. So grab your lycopodium powder. I know, it's very specific, because things are about to get weird.
Emily's Science Lab. Stay curious and keep exploring. Emily's Science Lab. Stay curious and keep exploring.
Today we are going to recreate a viral video I once saw online. It was this guy saying he could waterproof his hand with ginger. And I thought, well, I have ginger in my spice cabinet. I went and grabbed it and I thought, I can test this myself, which is what I usually do when I see something on the internet that feels just a little too amazing. And so I got my ginger, I poured it in. And this was my first red flag, because some of it is sinking to the bottom, which is not what happened in the video. And I thought, okay, well, we'll test this out anyways. And I put my hand in, and it was definitely not waterproof. So that was debunked. And then what I did next is I went online and I Googled, how does one waterproof your hand with a yellow powder? And guess what I learned? It wasn't ginger, it was something called lycopodium powder. Now, let's see how this looks different. So we are going to put our lycopodium powder on top of the water. Really good layer, so make sure you put it on a little bit thick. Now, watch what happens when I put my fingers in. Monster fingers. I can take my hand out, and my hand is completely dry. Why does this work? Well, 2 reasons. There's a lot of oil in lycopodium powder, and oil is hydrophobic, which means water-fearing. It literally repels the water. Actually, this makes lycopodium powder really flammable. You can see on here, it says it's also called dragon's breath powder. That's because it's used in those science demonstrations where somebody blows it out of their mouth and lights it on fire, and it creates that dragon flame effect. out. The other reason this works is because this stuff is so fine, and so it completely covers every nook and cranny of my fingers and my hand. And because of those two things, the oil and its fineness, we can create our monster finger effect, just like so. And my hands are completely dry. Remember the guy with the viral ginger video? He didn't use ginger, he used lycopodium powder. He was just trying to trick you. Thanks for making monster fingers with me. That was creepy and fun and delightful. If you like this one, be sure to check out my best-selling Stay Curious and Keep Exploring series for 99 more science experiments. I'm Emily Calandrelli. Subscribe for all things science and space. And remember, stay curious, think critically, and keep exploring. Bye.
Emily's Science Lab.
Have you ever wondered, how does nail polish remover work? Well, today we are learning about all of this and more with my disappearing act experiment. Hi, I'm Emily Calandrelli, MIT engineer and host of Emily's Wonder Lab, and on my channel we learn about all things space and science. So grab your styrofoam because things are about to disappear.
Emily's Science Lab. Stay curious and keep exploring. Emily's Science Lab. Stay curious and keep exploring.
Nail polish remover has something called acetone in it. It's what gives nail polish remover that pungent smell. Acetone is something known as a solvent, which means it can dissolve certain things. Now, nail polish also, surprisingly, has acetone in it. It just also has other chemicals that allow it to harden on your nail once that acetone dries away. So here's how nail polish remover works. Because it's a solvent, when you put it back on your nail, it dissolves the nail polish, turning it back into its liquid state, making it easier to wash it away. For this one, what you need is styrofoam. You can just use a leftover cup from a fast food place, some markers to draw on your styrofoam and make it fun, scissors to cut out your styrofoam, safety glasses because we're dealing with acetone here, and parents and adults because we're dealing with acetone. This is something that you should do and maybe have your children watch. You just don't want them to be touching or ingesting acetone. And then a bowl to put your acetone in. So what you're gonna do first is pour your acetone into your bowl or glass, and a little bit goes a long way here. You'll see why. So now, take your styrofoam and just slowly submerge it into your acetone. Do you see her feet dissolving away? Acetone is a solvent, and it is dissolving the styrofoam, turning it into this little gooey mush. And it becomes so much smaller than it originally was because styrofoam is filled with tons of little pockets of air. And when you remove that air, all you have is that little gooey styrofoam left. Now we can say goodbye to our witch. Okay, now I have a little spooky ghost here. So now my spooky ghost is going to see the same fate. Bye, ghost. Look at this goo. This is still styrofoam. It's just the styrofoam without all of that air. It just dissolved down into this. Gross. Trying to dissolve 25 styrofoam cups at once. I can sort of feel when I get to the lid because it's denser. What number are we at? 13. The acetone is dissolving the styrofoam, removing all of the bubbles inside of styrofoam and just making it into this little snotty goop. Oh my gosh, we're so close. Go, 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 go. And that is how you dissolve 25 styrofoam cups at once. That is styrofoam without the air. It has this like shimmer to it. It's actually very beautiful. Thank you for making styrofoam disappear with me. If you like this one, be sure to check out my best-selling Stay Curious and Keep Exploring book series for 99 more science experiments. I'm Emily Calandrelli. Subscribe for all things science and space. And remember, stay curious and keep exploring. I'll see you next time.
Emily's Science Lab.
Have you ever wanted to launch a paint can into the sky? Well, today I'm going to teach you how with my experiment, Exploding Witch's Brew. Hi everyone, I'm Emily Calandrelli, MIT engineer and host of Emily's Wonder Lab. And on my channel, we get to talk about all things space and science. So grab your paint cans and get ready for an explosion.
Emily's Science Lab. Stay curious and keep exploring. Emily's Science Lab. Stay curious and keep exploring.
To make your Exploding Witch's Brew, aka paint can rocket, here's what you need. A metal paint can with the lid, 1 cup of baking soda, 1 cup of vinegar, a rubber mallet, and some safety glasses. Eventually, we are going to mix our baking soda and vinegar in our paint can. But first, I want to show you what that's going to look like. So here we have a see-through paint can. We are going to add 1 cup of baking soda into our paint can and 1 cup of vinegar right on top. It's going to sit in a plastic cup and we're going to nestle it into the baking soda. And that's going to stay that way while we hammer on our lid really good and tight. You want a tight seal. And then eventually we are going to flip over our paint can and the baking soda and the vinegar are going to mix together. That kickstarts an acid-base chemical reaction that creates carbon dioxide bubbles. Let's see what that looks like. Ooh, whoa, 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 whoa. Okay, see all of those carbon dioxide bubbles building and building and building and building. Now, just imagine what would happen if the lid were on nice and tight. What do you think would happen to this paint can? Let's see it in action. Now we are going to make our paint can rocket, aka our Exploding Witch's Brew. So get your paint can, set it down on a flat surface. Parents and adults, let's do this one outside. And because we are dealing with exploding paint cans, we need to exercise caution here. Go ahead and put 1 cup of baking soda in the bottom of your paint can. 1, 2, 3. Shake it around so it's flat. Now we're going to add 1 cup of vinegar to a plastic cup. Now very carefully, so that they do not mix, place it gently on top of your baking soda. And the way that I do this is I sort of circle it around, creating a little bowl in the middle so that it holds on to that cup right there and it won't fall over. There we go. Now for the exciting part. It's at this point where you need to put on your safety goggles, like this. Now get your lid, and we are going to hammer this on nice and tight. So I like to do a star formation where I just hit this in the pattern of a star. One error that you might make is not putting this on as tight as you should. You really want to create a perfect seal, because if you don't, those air bubbles are going to escape and your rocket's not going to launch. Okay, let me check. All right, guys, our paint can is ready to go. In fact, it's ready to blow. Are you ready to flip it over? Are we? Yeah, you were ready? Okay, here we go. Paint can launching in 3, 2, 1. What? And that is a paint can rocket. Okay, we are going to make another paint can rocket, but this time we're going to do things a little differently. I'm going to use half of the baking soda and half of the vinegar to see if that changes anything. I'm trying to make my paint can go even higher. We'll see if that makes a difference. So I have my baking soda in here. I have my vinegar in here. I'm just going to nestle it right in the middle there, put my lid on, hammer it down well.
My hypothesis is that more baking soda and vinegar makes a more violent reaction, kicking off the lid too early. Maybe with fewer materials, we can get more air, more fuel to slowly build up before it launches.
Think that's good to go. One more for good measure. All right, launching paint can number 2 in 3, 2, 1. Whoa. And that is a paint can rocket. So what made our paint can rocket launch? Well, that acid-base chemical reaction inside made those carbon dioxide bubbles. And those bubbles were building and building and building. And so the pressure inside your paint can was also building and building and building until the lid couldn't take the pressure anymore and it popped off, sending all of that air rushing downwards. And because of Newton's third law of motion, for every action there's an equal and opposite reaction. Our paint can went upwards. Thank you for making a paint can rocket with me. If you like this one, be sure to check out my best-selling Stay Curious and Keep Exploring book series for 99 more science experiments. I'm Emily Calandrelli. Subscribe for all things science and space. And remember, stay curious and keep exploring. I'll see you next time.
Emily's Science Lab.
You're at a party and you're playing ping pong, and oh no, the pong falls off the table and somebody steps on it. And look, it's bent. All your friends look to you and they say, "It's our last one. Is there anything you can do to bring it back to life?" What do? Today, we will teach you how to bring a ping pong ball back to life with my experiment, Zombie Ping Pong Ball. Hi everyone, I'm Emily Calandrelli, MIT engineer and host of Emily's Wonder Lab. And on my channel, we learn about all things space and science. So pick back up those paddles because we're about to bring a ping pong ball back to life.
Emily's Science Lab. Stay curious and keep exploring. Emily's Science Lab. Stay curious and keep exploring.
For this one, all you need is your dented ping pong ball and a boiling pot of water. So what you're gonna do is place your ping pong ball in the boiling water. And we wanna expose the dented side to the hot boiling water. So I'm gonna use my tongs here. And parents and adults, because we are dealing with boiling water, make sure that you are doing this, not the kids. So we're gonna go ahead and put this inside. So we're gonna roll. Oh my gosh, literally, that was like 1 second in the boiling water. And we brought our ping pong ball back to life. That's all it is. That's all you do. So what happened there? Why did that work so well? Well, because when you squished your ping pong ball, you compressed the air that was inside the ball. But there was no cracks in the ball, right? So you just created a little bit of a high pressure environment inside your ball, but it couldn't overcome the force of the bented plastic. What we did here was we added heat to the inside. We heated up that compressed air. And when air gets hot, it wants to take up more space. We created an even higher pressure environment inside of our ball, and that forced the bumps and the bends in the plastic to go back in place. And so after you do that, you just want to set your ball aside to cool before you touch it, right? Make sure it's all cooled down. And then once it's cool, we can test it back out. And that is how you bring a ping pong ball back to life. Thanks for making a zombie ping pong ball with me. If you like this one, be sure to check out my best-selling Stay Curious and Keep Exploring book series for 99 more science experiments. I'm Emily Calandrelli. Subscribe for all things science and space. And remember, stay curious and keep exploring. I'll see you next time.
Emily's Science Lab.